So today, we're going to talk about the combination of data platforms with generative AI use cases. I'm Erik Schmiegelow. I'm a director at Hivemind Technologies, and we're a tech consultancy focused on helping our clients build modern data platforms and modernize their data stacks, utilizing state-of-the-art streaming technologies. So when we just think about streaming data products or streaming technologies, we're basically following a concept of the modern data stack, which is circling around an idea called data products. Right? A data product is essentially sort of a service that has near real-time streaming capabilities. And what that usually looks like is it's decentralized, it's source agnostic, so you can take data from anywhere, right? And can source it from operational analytical data sets. It's self-contained, right? A bit like a service. And it has standardized interfaces, basically answering async and synchronous calls. So, and the building blocks are, quelle surprise, Kafka as the de facto standard for streaming. We have Kafka Connect to basically get all those source systems integrated. We have stream processing capabilities that can be any kind of streaming framework, be it Kafka Stream, Spark, Flink, Quix, Zio, even if you're in the Scala community. You have streaming query engines, RisingWave, Materialize, and others. And obviously Iceberg, because you want to not only stream the data from A to B, you also want to land it, and you want to continuously update it as the data comes into your system. So, and in terms of data access, in a data product, you basically have essentially two types, right? You either have the ability to query, like using some kind of query interface, either a REST endpoint or a SQL interface, and you want to basically do a data access, or you want to subscribe to a stream of events. And all of that is guarded by some interfaces and data contracts. So when we're looking at a bit of an architectural picture, you basically have a domain, you have subscription, you have Kafka topics, you have different ingestion pipelines, let's say an SAP system, S3 buckets, RDBMSs, and you ingest all of that into Kafka streams, and you have some kind of view materializer processor, be it Flink or Spark or RisingWave, and you have a data repository that allows you to do queries or subscription. So very on a high level, this is what data products look like. Now, in specifically what we want to do in a data product is the ability to do data projections. And that's where we come back to that concept of sourcing from different systems and normalizing the different systems, regardless of their provenance, into a standard way of projection. So essentially saying, regardless of whether I'm basically subscribing from, let's say, a pub/sub Salesforce queue, or I'm getting a CDC stream from a database, or I'm getting some messages from directly into Kafka, I want to be able to say, I'm going to collect different attributes and different keys and different data sets from these sources and project them into a table that I can query, right? And I can create group bys and join conditions, essentially, and treat them specifically like a database. And that can be continuously updated as a projected view or table. So basically, the concept of materialized views, right? So this is kind of cool, because it gives us the ability to say, hey, whatever it is that we get into our data product, regardless of where it comes from, we can just basically harmonize that into the single representation in a join. Now, we've heard a bit in Yungjin's presentation how that can be done with different systems, notably also RisingWave, right? And when we look at RisingWave, we've done that in several projects. We can just basically import different queues from Kafka. We can connect to databases and pipe them into RisingWave, do some transformation using SQL, and project those as output sinks or views within RisingWave, and then push them simultaneously to different outputs, notably Iceberg, but also databases, queues, and whatnot. So this gives us the ability to specifically, in the context of RisingWave, to satisfy a lot of our transformation requirements without having to code anything specific, just by defining queries. That's quite a powerful thing because let's say the reality of a data engineer is that, let's say, 20% of the stuff that you're doing is really awesome. Like, hey, I get to write a really cool program to do some computation, and this is a bit really fun, and I'm going to deploy this in an app. And the rest, the other 80% is just, oh my God, I've got like 4 different telematics providers. They have 4 different inputs, 4 different interpretations of what that looks like, and the different attributes are called differently. And I need to project that into a single generic format. Yay. I don't want to write a program for this, but this is what I've got to do. Using RisingWave just makes that more simple and less painful because you can basically say, okay, that's the incoming source. This is what it looks like. And I'm just going to write some SQL, maybe even generate the SQL, and then just project that into a generic output and then use that forthwith, which also makes, let's say, projections and medallion architectures within the context of a RisingWave instance much more simple. We had a talk, Yungjun and I, about medallion architecture last week. And we're looking at that. If you want to catch up on the video, you can take a look. It's online. What's cool about RisingWave specifically is that we can basically have multiple parallel inputs and outputs. And regardless of where it comes from, especially using, let's say, Kafka as a conduit with Kafka Connect, we can basically connect to any kind of source system and pipe it out, mostly to, let's say, Iceberg, Postgres, Kafka, and other destinations. Makes it fairly simple. Now, what we're talking about today is how does that marry with generative AI, right? Because like as a data engineer, everybody talks about generative AI, but nobody really knows how to do this because in our normal lives, we just basically do deterministic projections and computation to transform stuff and maybe do some aggregation. All of that is deterministic, and then there's the GenAI stuff. What the hell is it? I mean, okay, we all use ChatGPT. We all have a sort of a notion what it does. And then there are all those other fancy kids and people in startups that are writing like super cool large language model stuff and generate cool products, et cetera. But how does that affect us, and how can we leverage that in our daily lives as data engineers? Now, there are a few things that we need to understand. So what's generative AI generally? Of course, generative AI is just a large language model that's trained on billions of text inputs and is very clever at predicting what text you actually want, right? So it's just a predictive model. But where it really took off was when people started thinking about using large language models rather just for text generation, but also to combine it with the ability to use tools. Hence the term agentic apps, right? So the large language model becomes the router to decide on what kind of code it's going to execute, which is essentially you're basically writing an app. It has a large language model. It gets a prompt, and you tell the large language model, look, you've got a calculator here, and you have the ability to execute a query on a SQL database. And I'm going to ask you to query the database and find out how many cars we've got in our fleet, and then add that to the number of pens in the cupboard in the office. And they're going to do that. And the large language model says, OK, I'm getting those results. Oh, there's the 2 numbers. And as I take those 2 numbers, I'm going to from the database, and I'm going to put that in the calculator, and I'm going to answer. So it basically gives the agentic application has the ability to do some limited reasoning based on probabilistic methods. That's kind of cool, but how does that affect our lives, again, as data engineers, right? Well, it becomes more interesting when we look at a new protocol that's been released a couple months ago called MCP. And MCP stands for Model Context Protocol. And it's just a standardization to integrate tools of all sorts with large language models. It's basically the rest of the GenAI space, right? So essentially, it's like a set of protocol that has a context schema. It's composable. It allows reading and writing context, and it has a standard interface that describes which methods it can invoke. There's a huge inflation of MCP tools out there for all sorts of systems that basically lets you plug whatever it is, be it a SharePoint system or a SQL database, or there's even an MCP implementation for Iceberg where you can query Iceberg tables, and you plug that into your instance of a chat, of a large language model, even your cloud desktop or your chat GPT on your machine, and you can basically tell it, okay, there's this MCP tool, I want you to do that, and it basically then formulates and executes a query on those systems. Now that becomes a bit more interesting for us data engineers because we basically have some kind of interfacing between an agentic application and our systems. Now, when we tie that together, we can basically say, okay, that's cool. We can deploy an application that takes a prompt, right, be it generated prompt or a prompt that you type into a chat interface, and it can integrate into our existing landscapes, right? It can also do some clever things like text to SQL, which is really cool, where you basically say, okay, I want to query this table. I don't know how to do it. I don't know SQL. There are people that don't know SQL, imagine. And then the chatbot generates the SQL, and it executes the SQL, and you get that result. It's really cool. And on top of it, it gives you the ability to also provide fresh data to generative AI applications, which is a real important thing. It's really crucial. Because let's say at the very beginning, like 2 years ago when chatbots or ChatGPT came onto the scene, well, it was just trained on a stale data set, and you could ask questions, and it would answer, well, I don't know that because my training data stops in October 2021, right? Now you have that ability to basically plug data sources into a generative AI application. But there are things that you need to consider. You can't just plug in a GenAI application into a stream and say, oh, this is awesome. I don't need to do any coding anymore because this large language model has all its tools and it can just basically do whatever. You know, I used to write a program that would basically scan addresses from a text, for instance. I'd use a huge parser combinator to do that. Well, I'm just going to plug in a generative AI application that will do that. Awesome. No need to work, no problems, etc. But the issue is generative AI applications have some really different characteristics to them compared to our standard data processors. Yeah, they are not deterministic, so there are no rules, right? In a program that we write in Spark or in Flink or whatnot, we can just basically write a test and it will always behave the same way. Generative AI applications are not like that because they're probabilistic. They basically say, well, you know, I generate an answer which I think is likely, right? And you may have the same behavior consistently, maybe not, right? Runtime behavior is also very sensitive to latency because the large language models need really a lot of processing power, notably GPUs that are in short supply, right? And on top of it, if you're using an externally hosted model, well, you don't know what that model will do in the future. The maintainers of that model may change it. So you may have model drift, and you may get different answers, even though you've changed nothing in your system. And agents, agentic applications need to also process a lot of different messages in order to maintain context. And context, or the ability to create a big window and to take everything into account, is limited, and it's a costly resource. And as I mentioned, it is much more expensive to run a generative AI application on a computer than a deterministic one. I mean, CPU is cheap, it's fast. Generative AI applications are slow, they need a lot of GPUs. So when we're looking at patterns on how to deal with those considerations, well, there is an aspect we call them observer agents. It basically comes from the observer pattern, which basically allows you to, or basically says, if your application is not really fast, non-deterministic, well, you detach it and you attach it to an asynchronous coupled stream. So essentially, instead of plugging your agentic application into the stream between two different pipes, you say, okay, I'm going to not do that. I'm going to create a proxy, deterministic proxy processor that flags up and selects messages and pushes them to that agent, and it can do that in its own time. That's usually what we do when we talk to third-party systems over which we have no control. It's basically the same for agents. And then it can basically do its thing. It can use MCP tools to process and come to different results, maybe generate some answers, etc., and pipes it back into another pipe that you can then, using eventual consistency patterns, join back into your stream as a materialized view. The good thing about this is that you have a division of labor. Standard data processors, they just basically select the stuff that you want to push into that agentic application, and they have control over the behavior and the back pressure and the runtime characteristics of your pipeline, just as you would generally do in a data engineering environment. You can group workloads to the agentic ones, so you can control also, you have control over context windows and data sizes, and you can optimize for that without affecting the runtime behavior of the entire system. It also gives you the ability to elastically react to workloads, and it does not affect throughput. So essentially, it sounds very much like reactive microservice design, because it is. It is a pattern and an approach that we use in reactive microservice, asynchronous reactive microservices. And obviously, it gives you more control over back pressure handling. Use cases for this are profiling, so risk assessment in financial services. So you want to use a model, a specialized model that gives you, let's say, the ability to observe a stream of transactions and mirror that and look up more complex use cases, create a risk profile, or score the data set according to specific heuristics. You can also do anomaly detection, which is cheaper and easier to implement than using classical ML-based detection, because these need to be trained, and you do not need to do that with, or not as extensively with agentic app implementations. And lastly, a very common use case is data enrichment and generation. So basically, you get a full data set coming in, and you want to create text that describes and annotates the data that comes in for reporting purposes. You can do that asynchronously and without affecting the pipeline, and that basically makes use of generative AI capabilities within the data processing, data stream. The other common use case for agents is assistive agents, essentially building tools that help users interact with the data platform, specifically translating, as I mentioned earlier, translating natural language, German, English, French, whatever, into SQL, execute that, and return results. We see more and more dashboard systems adopt this approach. It also allows users to do self-service report generation. In the daily life of a data engineer, report generation is something that we all hate, right? And a lot of our time is consumed by creating bespoke management reports for X, Y, and Z. Well, with generative AI, you can actually build self-service environments that allow a relatively easy interaction based on chatbot interfaces for users to create their reports, pipe that to an MCP tool that talks either Spark Connect or Iceberg or Postgres, and Bob's your uncle. Most of the reports are gone. You don't have to do that anymore. And lastly, what's really practical is to create a narrative for reports. Often just dumping data onto users is not helpful. With GenAI, you can create a narrative that explains specifically what the report says with a bit of context. What that looks like in practice is something that we like to do with Apache Flink. Apache Flink is really cool in that sense because it has interfaces within its runtime to call generative AI applications within the stream, which is really cool, either with REST gRPC or with the ability to integrate the generative AI and agentic frameworks such as Llama Index or LangChain, which allows us to create agents that we integrate within a Flink job. So that makes it quite easy to build the observer pattern that I mentioned before. We basically have a Flink job, selection, call to the large language model interface, plus the generation. One example here is to essentially say we want to annotate a report. So we create a UDF. I don't know if that's a bit tiny, but let's say the bigger screen basically defines the UDF, right, and gives a prompt to generate context for a specific report. And in the smaller screen, you see basically just a Flink SQL query that calls that UDF that basically just creates a generation and outputs that into a Flink table. So really cool, fairly easy to do, and fairly easy to integrate in a pipe. Lastly, when we look at what that looks like as a data product, well, we can just basically integrate that stuff with Flink, for instance. We have also RisingWave for most of the 80% of the lifting and conversion, which we really like to do at Hivemind. And for the 20% difficult stuff, which needs computation, we use frameworks like Spark or Flink. And in this case, we want to do some generative AI calling, so we just basically use a Flink GenAI-enabled processor that either calls a large language model for generation directly or calls an agentic implementation that calls an MCP tool. So it makes it fairly easy to add and augment our data platforms with generative AI applications, specifically in the context of machine-to-machine communications. So not the classical thing, I'm talking to a chatbot and gives me results and it's sort of copy-pasted somewhere, but specifically in the context of streams, stream input and stream output. So I'm coming to the end of my presentation. Any questions?